Hello everyone, have a great day to you all, and we are meeting from the another session of the introduction to data center. This is Rumesh De Silva. I'm a data center professional and a certified trainer, and I hope all of your surrounding is much pretty good and it's okay. And in the previous sessions, we have been able to discuss about the introduction to a data center and the what is IDC and what are the types of data centers, co-location, cloud, and hybrid, and the key areas of the data center, and what are the standards and certifications of the data centers, and the kind of security frameworks and lead goal certificate likewise, and the how we will be able to rack and stack principle and rack and stack, how we can be able to rack and stack server inside the data center, and the power infrastructure standards and the power infrastructure details with the cooling and the standards and what I call a cooling mechanisms of the data center, like as we have been discussed. So you may go through the previous sessions and you will be able to get a pretty much good idea about the data center infrastructure. And also today we are going to discuss about the network things inside the data center. Students and the my friends. In the right hand side of this slide, you'll be able to see the very compatible uh, three-tier architecture of the network. You may see the core switch architecture and the aggregation switch layers, and also access switch layers, which are passing the layer 2 traffic VLANs, likewise. In the left-hand corner, uh, you'll be able to see the spine leaf architecture of the data center. So why do we need a spineless architecture rather than the tier 3 or 3-tier architecture? Why do we need? Any idea? Do you have any idea? Please do a kind of a comments in the comment section in your suggestions and your knowledge. So it will be really helpful to me and others to learn and as a knowledge sharing. So, however, mm, traditional three-tier data center. So you may see if this server wants to communicate with that server, this server wants to pass layer 2 traffic into the VLAN from this access switch and then this aggregation switch. And it has to go for the core switch as well. And the only going after core switch, again, that traffic wanted to come like this path. The lengthy path, the longest path, the many collision here and there. That's why we need a spine leaf architecture. That's the one reason. If this server wants to communicate with that server, simply this is going to be asked from the leaf switch, the spine switch, directly to the server through this leaf switch. Less collisions. If you need to scalable or edit or put another server or host into this, right? You have to spend much kind of a higher cost, high cost actually, to increase this one, increase or scalable or edit this network. But that is not happen in the spine leaf architecture. And again, I have to tell you more about this scalability, low latency, which means low collisions, high bandwidth utilization can be happen inside the spine leaf architecture, and a good redundancy source, and simplicity, and efficient east traffic transferring. So the support for the virtualization. If you are going to build the cloud architecture, definitely you may use the spine leaf architecture. Really helpful for the virtualization. And also nowadays in the present data centers, most of personnel are using the Cisco products, Cisco Nexus series to implement the spine leaf architecture, right? So, I have to tell you another things, the few things about this slide. So here, this is the prototype of the network architecture that I have been built for some purposes of the design purposes of some data center. So here, uh, as you can see simply, here we have implement number of two providers. Normally, providers are connected to the MPLS network for the intranet traffic handling, and the ISP devices we are putting to getting connected to the international traffic flow, right? But in this diagram, I have only shown the what I call providers only at this time. And you can see the number of two core switches here and number of two firewalls kept beside of the switch, and another TOR, top of rack switch series, you will be able to see in this diagram. So, and again, here under this TOR, switch 1 and 2, you have seen actually two switches, switch cluster. So, switch 1, switch 2, this what I call this stuff has been kept for the what I call in WAN or internet services in the data center. You know, in the inside the data center, we are going to host the DNS servers, emails, web hosting, proxy, web application firewall, likewise things. Under this cluster of TOR switch, we have put a PaaS, platform as a service, infrastructure as a service, video surveillance as a service, software as a service, storage as a service, likewise. Many cloud services under this cluster. And you know, my friends, actually, once you are putting your physical server inside some of the data center, so definitely you are needed to getting connected the internet service providers links to your server through the firewall, even through the access switch. Somehow you have to use the telecommunication devices. So this network for the implementation or hosting the telecommunication devices. And also, and my dear friends, again, you know about that. Extra low voltage services must in the data center, because inside the data center, we have monitoring tools, CCTV, access control, rodent repellent system, and the WLD, water leak detection system, and the fire detection and protection system. Likewise, many supportive systems and the data center infrastructure management system. Likewise, infrastructure monitoring system, DCI. So in the inside the data center, there are many of ELV network supportive systems which are going to be maintained on the ELV network. And also and also and also here. So we think about my friend. So someone is there named Saman. So someone wants to host someone's physical server inside the data center. We call it as a corporate customer location. We are allocating required unit space from one rack to the someone. Someone is coming with the server and mount inside the rack, and going to be powered via two redundant power sources. So someone needed the connectivity. Yes, someone's router located at the telco room, right? Or someone's if someone is not using separate router, we will be able to use the spine or business edge for the direct connectivity of the someone server. So I'll explain actually how it works. How it works. Definitely, I'll explain you. We think that so someone is at home right now. Someone wanted to getting connected to someone's server. So how it happened? Actually, we have what I call a few methods via the firewall rated VPN, and the and what is other one is uh, point to point link, P2P link, P2P link, likewise thing. We think that what I call someone has someone's own firewall. So this firewall has a public interface. So someone is first of all, someone also has a public internet connection. Someone is getting connected to the firewall via the application, VPN application. Already someone, if someone has internet connection, already provided as OISP, the switches already has the internet connection. Someone is coming to the provided, let's think as an example. So traffic is coming to the core switch, and core switch looking at actually uh, someone's VLAN, someone's firewall public interface VLAN. We have that through this file switch. Directly this traffic is coming to the someone's network. Either if someone is using the point-to-point link, that time also someone will be able to reach to the provided and after the core switches, and core switches say someone is at under this top of rack architecture. And the other one is we think that someone has no the separate firewall. So, but someone is purchasing the virtual firewall from the data center management. So then only if someone has internet connection, simply someone is coming like this. Someone is coming like this to the core switch. Someone's firewall maintained under data center firewall. So someone is coming from the public side, and once reach into the firewall virtual domain, it says this traffic has to behave like this. So because we have put some kind of rules and firewall policies. So firewall policy says, yes, of course, your server under DMC is on, and the traffic is returned from the DMS on and going to the specific server. Simply, I told you, once you are configuring VDOM, how you can do this and everything, how you can create the net and the addresses, all will be explained in next few sessions, definitely. So simply, I wanted to tell you inside the data center, there are a separate networks we have to maintain and separate architecture. As of now, I guess this is enough for now uh, for this slide actually, not for all. Let's move to the next slide. So I'm going to explain via the next slide how customer is going to be connected uh, to the outside. So this is customer rack. This is customer rack actually. So customer rack consists number of two switches, access switch 1 and access switch 2. And both switches connected to the customer in router, which is located at telco room A and telco room B. This is from one ISP, this is from another ISP, and this is customer's dedicated router, and this is the top of rack switches which are using to the getting uplink for the customer in router. If customer is using kind of a customized services like what I call the link like so Visa Master somehow, Data Clear or somehow dedicated to LFSB, somehow dedicated links only we can put the router. Otherwise, customer in just internet or VPN likewise thing, directly we can be able to provide direct links from the direct connectivity via the transmission medium, even a Ethernet or fiber from the TO1. But we are using separate router if we are using kind of a customized service, we have to use that. So both telco rooms are going to be connected to the core switches, and the core switches are going to be connected to the business edge or provide edges, and the how traffic is going to outside via the undersea network connectivity. So simply, I could explain you how customer physical server is going to be connected to the what I call inside the network. Right? So I guess the next topic is a software developed van, and if you have any kind of a questions, please discuss in the comment section. I will ask you much as possible with my busy schedule actually. So I guess this is enough for today. Let's wind up today's session from here. Have a great day to everyone. Please reach me via LinkedIn, and you may be getting, if you need any idea or clarification about data center or any opportunities, please contact me via LinkedIn. So have a great day, everyone. Bye bye.